Good morning, and we'll be starting up at top of the hour, 9 o'clock. If you want to, go ahead and go to the website polev.com, David or PE. We're going to be using that to get some interaction today. Or you can actually download the PoleEV app for your phone and then type in the name of the program, which is David or PE. It's easy to remember. And also welcome to those of you who are joining us on Facebook. We'll be live on Facebook, but if you're looking for professional development hours, you do need to be on the Zoom side of the house. And again, for those just joining in, if you want, you can either download the PoleEV app, Pole Everywhere, or you just go to the website polev.com and then /David or PE. That will bring you to where we're going to actually have some interaction during the course of the hour this morning. And if you look in the chat pod, you'll see a link to our roadway and roadside drainage workbook. A lot of what we're talking about today comes from that workbook and other resources that are mentioned in the back. So good morning, and welcome to another Topical Tuesday webinar. My name is David Orr. I'm the director here at the New York State LTAP Center, the Cornell Local Roads program. And glad to have you joining us today. Hopefully we'll have a little bit of fun as we go along. Now, we're going to be going for an hour this morning. So just to get you started, as a reminder, if you haven't been here before, first off, we're going to be using an interactive feature called Pole Everywhere. You can go on the website, polev.com /David or PE. And you can actually, so it's actually sort of fun. You can have a little bit of fun. And if you want to, you can even download it on your phone. And you can just play with it if you want to that way and just put in the answers. It's sort of cool. Okay. In fact, I almost forgot to do it myself. But it fits in your phone, which of course the background won't let you see. But we're going to be using that during the course of the hour. Your audio settings are down below. Everybody is muted, and the chat feature is turned off, but please open the chat pod up because we'll put links in there that are useful. For instance, you can actually download the workbook we're going to talk about and other things we want to get out to the whole audience. We will be putting things in the Q&A pod, and we may ask you to raise your hands now and then. Okay, so good morning, and we'll go ahead and get started here. And again, if you have any questions, let us know. We've got Amanda and Adam watching in the background. Excellent stuff, and it should be sort of fun. Okay, now this is worth one professional development hour here in New York State. Only the person who is registered can get the credit. It is considered a course here in New York. What will happen is after the webinar, you'll get a certificate of attendance from Amanda just for attending, about 3/4 of the entire webinar. But if you need the PDH, you need to stay on the whole time. So not just 75%. So send us your certificate of attendance, and then we'll get the professional development hour back out to you. If you're calling in from another state, check with your LTAP center. They'll be able to tell you exactly what the rules are for your state. Most states, you should be okay, but again, you'll need to check with them to be sure. Now, again, a lot of the stuff we're going to talk about today comes from our workbook on drainage called Roadway and Roadside Drainage. You can download it. There's a link to it directly in the chat pods. You don't have to remember this or write it down. You can also just search for that. And New York State LTAP or Cornell Local Roads, either one will work. But that's what we're going to use. There's references in the back, so some of the things we're talking about come from there. But overall, we're hoping to help you solve your own problems. So we're going to start with our first PoleEV item. So here's how this works. You can go to the web, just search for polev.com, David or PE, okay? Or you can, as I say, do it via the app, and we'll give folks a couple of minutes. This first one I know will take some time for you to get to that website. Okay. And so, in fact, let me just go ahead and do that myself. And that way, I'll put that into the chat pod for you. So if you haven't, you can just link right from the chat pod. Just click on that and it'll take you right to the right website and you can put your answers in. And what I would like you to put in there is some common drainage problems. Okay, it's all anonymous and there's our first one, erosion. Yep, that's a common drainage problem. So what kind of problems do you see, especially on roads, that are related to drainage? Sloughs, slides, yep. More erosion. It's getting bigger. A lot of people put erosion down. Flooding, washouts, yep. Okay. Deterioration of the roadway, premature failure, yep. Culverts, structure problems, instability, blockages, standing water, yep. Base issues, yep. Monsoons, floods, yep. Right-of-way issues, which, yeah, if you got a limited right-of-way, that can cause you problems, okay. Plugging. So obviously, drainage problems are pretty severe when it comes to highways, okay. Um, and you can also do this via the Poll Everywhere app, Mark. Either the website or the app will work. It doesn't matter. If you go to the Poll Everywhere app, you would just search for David or PE in the app and it would come up. But you can also go to the website that's in the chat pod. Now, when you start thinking about it, look at all the answers we've been given. And that's very true. Most of our problems are caused by that. Common drainage problems on roads actually include even more than just erosion and washouts and culverts. It actually is cracking and rutting of the roadways, heaving. Almost every problem that's on our roadways is made worse by poor drainage or drainage issues. And so what I want to do over this hour we're together is to help you solve your own problems. Okay? Now, most people, when we think of drainage, we think of flooding in the spring, or actually, this was in January during a January thaw, when you get all that snow melt and runoff and create huge volumes of water. And we fear that that gets into the roadway system and we wind up with something like this and we lose the roadway. And yes, that's a drainage problem. But what I really want to focus on are the things that we can do ahead of time to maybe keep things like this from occurring. Now, of course, one thing that could help is you could employ an army of engineers. Mother Nature has an army of engineers out there, the beaver. Okay. But like anything, if something fails, it can actually make the problems worse. So we got to be a little careful with our friends. Um, there's actually times when the beaver dam failures can actually create floods of their own. So here's our first problem. So we have a roadway, badly cracked. Outside edges actually look okay. Um, So what I'd like you to do is, in Poll Everywhere, you can type in, what do you think the solution is for this particular roadway? You could also type in what you think the problem is too, by the way. In this case, it won't be a word cloud. It's going to be a series of answers. Maybe putting it under drain is a possibility, okay? A couple of people have put that in. That's good, okay? Maybe a better base. Yep. You got to get that sub base to drain. Yep. There's water underneath. Maybe it's a base problem. Yeah, very good answers. Improve the base. Okay. Could be a good candidate for full depth reclamation, or sometimes called FDR. Maybe there's not enough of a crown. Okay. So all great solutions. So let me ask, how do you know whether it's just a crown problem, a base problem, or even if it's a candidate for full depth reclamation? How do you know? You could do some cores. Yep. Cores is a good possibility. You could do a core sample. I like core samples. They're not a bad idea. If you can, and it's not always possible, your budget is definitely part of it. I like test pits. And my reason I like test pits is because if I've got a test pit, I can come in and I can go right across where there's changes and see what's going on. And a test pit, you can set it up so the water drains out if you do it right. And so you can see if there's a difference. It turns out in this particular case, a test pit showed the center of the road, where the bad crack section is, was actually the cleanest. The problem was the outside area was really dirty. None of it so dirty you couldn't reclaim it, but the outside shoulders were really bad. They were so bad they had to be thrown away. So as we're talking about solutions, think, how do you confirm what you think the answer is? We're going to stop a couple of times and talk about that as we go through the course of the day, okay? Or the hour. Got to remember it's an hour. Now, this is an old photograph, but you can see a road. This road was chip sealed about 9 months before I took the photograph, okay? We're looking down a hill, road's coming around the corner. Looking at it, what do you think is the problem and the solutions? And watch this trick. We'll see if this works. I'm going to clear the responses up so we get new responses in. So what do you think the solution is here? Maybe a full depth reclamation with new gravel? Yeah, it's a possibility. Yeah. Four slopes closest to the edge of the road. Maybe there's some problems with the side slopes. Maybe the water can't get away. Maybe the ditches aren't deep enough. It is a possible candidate for edge drains, especially along this inside edge. Okay. The hillside, it's always good to look at. Maybe do that. Now, a photograph is hard. We're going to see that. It's going to be a challenge for us as we go through. I know that. That's just the nature of the beast. This is the actual road sort of at a different angle, a more recent photograph. You can still see that it's got lots of cracking. But if you look, there's actually plenty of drainage on the side. The ditches don't really need to be any deeper. There's actually a pretty good crown, as you can see over the edge of that little rise there. The biggest issue is the quality of the material underneath. Just like before, a test pit or a core to see what the fines content is really important. And one of the things we know from work we've done for decades is when you look at what's going on, you want to have the right fines content in your base and your sub-base material. Fines, clays, and silts create water problems. They hold on to the water and they don't allow the water to drain out, even if you've got subsurface drains. So here's a situation where we've got ourselves the map of different material types, percent sand, percent gravel, percent silt and clay, or fines. And you really want to be in this little blue window here. So 50 to 70% gravel, good sized particles that are going to help hold things together, give you strength, give you drainage, a little sand to fill in the void so it packs and doesn't move under traffic, and then as little fines or as many fines as you need. If you've got a paved road, you want to get that fines content under 8%. But if you have a gravel road, you need those fines to bind it together. So just for the sake of argument, let's just see, of the 50 or so folks who were on there, raise your hand if you have gravel roads in your system. Okay, you go down to the bottom of the screen, you can raise your hand. Let's just see how many of you have gravel roads. 1, 2, 4, 5. Let's give you a couple of minutes if you got gravel roads in your system. Okay, so 8 to 10 of you, that's pretty good. Okay. The reality is almost every road started as gravel. But if they started as gravel and they were in pretty good shape, they probably have more fines than if they were underneath blacktop initially. But over the years, we pave over them. And that's actually what had happened in some of those previous examples. People paved over the top, and now the water couldn't evaporate and it fell apart, especially in the spring. Okay. So it's one of the reasons, like cores, like test pits, one of the best ways to solve some of our drainage problems is to do some testing ahead of time to see what's going on. Okay. So here's one. This is a crack running down the roadway. You can see it wandering here. It's sort of a wandering, meandering crack. Okay. It actually wanders over here. Okay. So in this particular case, What do you think the problems are? And I'm going to clear the responses real quick. I apologize if I got rid of one of yours, so I'm going to make you put it back in. I apologize. But if you have a question or you have a comment on a possible solution. So what do you think the problems? There's movement in the subbase. There's definitely some movement. Yeah, some trapped water in there. Yeah. Yep. Yep. Absolutely. This is actually one of those trick photographs. It looks like the problem is in the wheel path. Be very careful when you see a crack. Just because it's in the wheel path, it may be more common in the wheel path because of traffic. But if it's moving and meandering like that, it's probably more likely due to other things like motion in the subbase flexing. In this case, it's actually frost heaving. Okay. And yes, it looks like the cut and fill is failing. Okay. Crack sealing is a possibility. The problem is it's too late. If you think about the cracks, think of all the cracks, how parallel they are. If you put them all together and they're more than an inch wide, it's too late. And if you think about it, that's all these cracks are way too wide. You have to get to them much earlier. And then, of course, what's the underlying problem? In this case, there's a movement between the cut and the fill. If we looked at this from the natural landscape, okay, see if my pen will right here. It goes from a cut on the right side of the photograph to a fill on the left, and they move differently in the winter due to heaving. Okay. Long term, that's going to be hard to fix, but short term, it might be worth thinking about where's that water coming from. Anytime you've got a side hill situation where the land around the road is tilted from one side to the other, think about catching that water before it gets to the roadway. Maybe a subsurface drain here on the uphill side could be very useful. Okay. But they've done some crack repairs, but it obviously didn't quite do what they hoped it would do. Okay. And of course, what does this lead to? Well, you get enough water coming out, you can actually get something like this. This actually was sent in. It's an actual county road, and the water coming out was actually clear. This is actually water pushing the asphalt up in the spring. Okay, a frost boil that's blowing up into a big frost pimple. Okay. Again, catching that water before it gets to the roadway is a possibility, something to think about. Now, of course, that can lead to potholes. Okay, so our next problem we're going to look at when my computer decides to say hello is a pothole. Okay, now this is a shallow one. We've seen deeper ones. But when you see a pothole, especially when you see a little bit of water in it, there's a couple of possible solutions here beyond just patching. Okay, I know you may just patch it short term, but longer term, what do you think the solutions are here for this particular type of situation? When you see potholes, what are you thinking about? Moisture. It almost always comes back to where it is. So you could install tile. That's one of the primary ideas here, or a French drain, which is frankly a subsurface drain that typically doesn't have a pipe. You want to remove that water from the subbase. It could be due to an ice lens freezing underneath. It could be a base problem. And this is the key. You've all hit on it. Really nice job. If the problem is water coming in from the side, like we saw with that road pimple, the idea would be to put in and install a French drain or a tile or catch the water before it gets to the roadway. Intercept. Okay, so one possibility is to put a subsurface drain, figure out where the uphill side is, cut it off. Okay, so possibility one would be to put in a drain. I don't know why the computer decided to do that, but we'll live with it. So we put in a drain. Okay, but if the problem was a dirty base and you put a drain in, what are you going to have next spring? You don't need to put it in. You all know you're still going to have potholes because you've got a soft base. You can't get rid of the water with a subsurface drain if it doesn't want to let it go. If you got a lot of silt and you got a lot of clay, you're going to have more problems. So make sure you've got the right solution for the right problem, because the other solution here is to I'll just put in rehab, which could be a FDR. It could be boxing it out. Depends how big of an area it is. but bringing in full depth repair with base work as is in the solutions list. If, on the other hand, you hadn't checked and you thought the problem was a dirty base and you replaced what was there with clean base, but it turns out it was already a clean base, and the real problem was side water coming in, what are you going to have next spring? You're still going to have potholes. And so you need to make sure the solution matches up to the problem. That's really important, okay? So let's go to our next idea to think about. Let's talk about subsurface drains a little bit. This is a subsurface drain, okay? Now, we'll talk a little bit about backfill and subsurface drains. We don't have a lot of time in a 1-hour class, but when I see things like this, I go, ooh, what's going on here? Now, just for the sake of argument, the water is coming from the right side of the photograph, going to the left. That's a driveway culvert, okay? And you can see there are actually 3 subsurface drains there. 1 white that's got water coming on it, and 2 black. So what do you think the problems are here? What are the solutions for subsurface drains? I like subsurface drains, but we need to be careful when we install them. What are the concerns here? You need probably a higher invert. A rule of thumb is you really want to have that 6 inches to a foot below the bottom of the ditch because you know it's going to fill in over time. And by just having it dump out, you can create an erosion problem, okay? And you may be moving the problem. And white pipe is scary. Is that a leach outfall or did they just cheap out? Anytime you don't have black pipe and you expose it to sunlight, it's going to break down. By the way, the same thing's true with your hard hat when it's not black. Now, I wouldn't wear a black hard hat because it's too hot in the summer, unless maybe you're a Pittsburgh Steelers fan. But they break down. We add the carbon and other chemicals to help it survive in the sunlight. But if you don't have that, it's going to get brittle, and that white pipe is not long for this world. So really, it's the white one concerns me for a lot of reasons, I agree. And of course, none of these have animal guards on them. And so that would make me nervous as well. Okay. Now, again, we don't have a lot of time to talk about. We're just trying to go basic problems. So now we see a roadway like this. Okay. Cracked. Somebody's done some crack repair. So I don't think crack repair was the right solution here. What do you think is the right solution? And let me clear the responses. There we go. What do you think the proper solution is here? You probably got to box it out. Yeah. Yeah. The subbase isn't draining. In fact, if you look there in the upper left of the photograph, that's water coming out of the roadway. So you're probably going to do a cut and fill or a box out, a full depth repair. How much of it you have to do depends on the length of the roadway that's got the problems. But the reality is, you crack repair, it's too late. And again, that rule of thumb is pretty good. Just take the cracks and combine them together. And if they were one crack, would they be more than even 3/4 of an inch to an inch wide? If the answer is yes, it's too late. You got a bunch of parallel cracks like this, it's too late. It's already alligatored, as they say. So really, you need to do more than just crack repairing it. What's even worse is the day after I took this photograph, they overlaid this particular roadway, the agency that owns it. And of course, within a couple of years, evidence came back. That pothole showed right back up. The cracking showed right back up until they did something much more extensive to fix the problem more permanently. Okay. I like crack repairs. We don't do enough crack repairs, but pick good candidates. And if at all possible, give yourself at least 1 season between when you do the crack repairs and any kind of overlay work. And that includes a chip seal. Anything you're putting over the top, give that crack repair time to cure out. So a great time to do crack repairs, if you want the chip seal or overlay this year, is once the weather breaks. It's actually a good time because the cracks are at about the right width if they're moving as well. So something to keep in mind. Okay. So we're going to look at a couple of different road problems, and then we're going to talk about both of them together. So here's the first road. Okay, you can see was a chip sealed roadway, or at least it had evidence that it had been a chip sealed roadway at one time, but the chip seals completely failed. Okay. Um, from what I can tell, talking with the highway superintendents, the chip seal never really worked, probably because the base was really better for a gravel road surface. But the problems they're getting now aren't necessarily just due to the quality of the gravel. And then there's another road, obviously a completely dirt road, that's getting rutting problems during the spring. Both of them have something in common. So, what do you think the problem is, and what do you think is the solution? On the first try, y'all are getting good on me. Yeah, it's a drainage issue, and real issue is the cross slope. You got to scarify it. You may need to add base, but the really issue is the crown. Gravel roads, especially, need a crown. Okay. And it doesn't matter how good the ditch is. The ditches, yeah, there's a couple places on this ditch that could be better, but the big issue is the crown more than anything else. Gravel roads need a crown. I'd rather see it crowned all to one side. Here's a photograph taken this past year, and you can see there's a crown on the roadway. Okay, that's going to make a big difference. Now, one thing you can note, gravel roads, this is one of the hardest things to do on a gravel road. When you're coming around a corner, because you want that safety with the super elevation, you can sometimes, it's hard to not put in a flat spot. So it's something to be aware of and be very careful. Best thing to do, because it's a gravel road, put it in, check it, and then plan to go back after a year's time and see if it's starting to pothole up. It's relatively easy to fix early with a gravel road. If you wait till the potholes get deep, remember you have to scarify under the depth of the pothole. If you can catch it early, you might just be able to do a little bit of small scarification, put a little gravel, get that crown in there, and walk away. Okay? And as soon as the grass grows, you're in pretty good shape. Okay, so now we're in more of a hamlet area, okay, or the edge of a village. What do you think the problem is here? And let me clear the responses here real quick. Okay, so what do you think the problem is here? No drop inlets? Yeah, there's in an urban area, whether it's a hamlet or a village or a city, we need to get the water away from the roadway. And a lot of times we have problems. We can't put a ditch in. You have nowhere to really drain the water. You have nowhere to put the ditches. You may even have curbs and gutter. And so you're going to have to think about subsurface water systems, drainage systems to collect that water. You might be able to get away with a swale in a lot of cases, and you might even be able to put a swale off the roadway. Okay. But you got to think about that water. You can put an underdrain system in, but realize you need to design it for the volume of water. That surface water is more than most subsurface drains really like. So you may need to account for that and put larger pipes in and think about the outfalls, okay, quite a bit. How do you keep the water from the road and how do you take it away? Because that standing water is obviously going to lead to a premature failure. Okay, nice job. Now, let's clear this and look at the next photograph. So this one, not going to be a solution this time. This is a shoulder on a roadway. Now, it's not a curb and gutter, but we'll come back to the fact that they're similar. What is the purpose of a shoulder? This time it's not the solutions answer, it's what is the purpose of a shoulder? There should be 4 answers here, I hope to see. What is the purpose of a shoulder? Snow storage? Yep. That's usually one of the last things we think about. Okay. Storage, recovery for safety? Absolutely. You know, that errant driver who's paying more attention to their cell phone? Yep. It provides lateral support. It actually helps hold the pavement in. Okay. If you get edge cracking on your roadway, it's probably because your shoulders weren't compacted or your curb and gutter weren't placed real well. Yeah, nice job. Good answers. Emergency, edge of the roadway, helps the asphalts. And of course, it takes the water away. It's a drainage issue. It takes the water from the road to your subsurface drains, gets it off the roadway. Okay. So yeah, nice job. That's what the purpose of a shoulder is. So if you're going out, you're looking at your road system, especially as we start to get towards the end of winter, We know we've been using sand, and even with salt, there's a buildup, and we start getting buildups like this. We need to think about cutting those shoulders down so they're actually doing the job. Because obviously, if the roadway is completely covered with uh, the side, water can't get away, the roadway begins to crack, as you can see in here, and we could drive ourselves nuts. If you start looking at this, it's too late to crack repair it. And a lot of that is caused because the water is trapped on the roadway. So as we get towards the end of winter, think about where you want to cut your shoulders, get that water off, do it properly with your grader, and go from there. Okay? So now let's switch gears, and now let's talk a little bit about culverts. Okay? And is your culvert big enough? So if you know, okay, if you know, just let me know, what is your design storm for culverts underneath the roadway? Okay? Not the ones for driveways, but what's their most common design storm for culverts underneath your roadways? Okay, let's go see what we got for answers here. Okay, so most of you are trying to do 50-year designs underneath your roadway. Okay, that's fine. 25 years, pretty common. So a few of you 100-year. We should actually be designing our culvert sizing to match up with the risk that we're willing to take. Okay. Really, probably even a small town probably should have different size storms that they account for on different types of roadways. Now, when I put in the percentage behind the year, that's done on purpose. It's a phrase we're starting to use. Instead of the design storm of 10-year, we're calling it a 10% storm because each year is unique. What are the chances in a given year that you're going to see flooding? And we know we're going to see more extreme events with everything that's going on. We need to account for that. The averages aren't going to change much, but that means we probably need to put slightly bigger pipes in. Not huge, because you don't want them oversized, because you're going to actually create problems downstream. Okay, so it's just something to be aware of and keep in mind. You might want different size pipes. For instance, the road to the hospital or the school probably needs to have a bigger pipe in, handle a bigger storm. The interstate, they're shooting for 100-year storms or 1% storms. Uh, Less risk, bigger pipe. Okay, but just as important, and is we install those pipes. Okay, so here's a pipe. You can see a photograph. There is my snuck-in picture. I do this whenever I can. That's actually Lynn Irwin, our old director, sitting at the far end, facing and staring at me. We were looking at this culvert together. We noticed a couple of things. What do you notice as might be a problem here? And what are some solutions once you've put the pipe in? Possibly a scour. The joints, uh, they were metal collar. They weren't great. We were really concerned about the structural support. It's a corrugated pipe. Yeah, some people don't like corrugated pipes. If you have the proper lining and or gauge thickness and material type, corrugated pipes actually have very long lifespans, but you've got to match them up to the soil conditions. The state's highway design manual actually has a really good chart to help you figure out the right gauge and coating for your particular pipe wherever you are in the state. If you're in the southern tier, for instance, you need to have thicker pipes and different materials and liners than if you're in places where the acidity or the pH is different. Okay, good information. Go a little thicker. It's really cheap insurance. Get a good lining, either a polymer or an asphalt or even concrete, but protect that pipe. It will actually last the 35 to 50 years you want, as opposed to 10 or less. Okay, so put in the right material. I would tell anybody anywhere in New York State, if you're putting in corrugated metals, if you're not going to put aluminum pipe in, put in aluminized steel type 2 at least. Okay, and go a little thicker gauge than you might otherwise. But the thing I'm always concerned with these pipe arch pipes, and they're sometimes called squashed pipe because that's how they make them. When they squash the pipe, they sometimes put in a bit of a crease. Okay, you can see the crease there. There's a bit there. those are prone to issues. We've all done it. I'm not going to say that we don't have pipes in all over that have this issue. But when you start and put those in, better to not have that. But if you do have that, you really need to start watching very carefully how that pipe does over time. And the crease is right at the spring line too, which is one of the worst places. So when they fail, they can fail very, very dramatically, like this guy here, where the support was lost underneath. So when you get those pipes in, you might want to have some limitations on how much of a crease you allow. And if you backfill them, you got to backfill them very, very carefully and make sure you don't lose support underneath. We should be inspecting our culverts on a regular basis. We don't do that enough. The bridges all get inspected every 2 years. We really should be looking at our culverts, maybe not every 2 years, but certainly anytime we're doing major work on the roadway, have somebody go down the road and look at every single pipe, including the driveway pipes. And if it's not going to last until the next time you expect to do major work, that's time to start replacing it. In fact, if you can do so, it's actually really good if you do your inspections, even in the winter when it's not snowing like this year, replace 1 year, and then do all your road work the following year. Yes, that's a 2 year cycle, but you really get good work then. You get yourself time. And money is tight, time is even tighter. Okay. And of course, the installation is really the key here. Okay. The installation of pipes, how you install them really matters more than anything else. So keep that in mind as we're going through. Okay. Take your time, do it right, and we'll go from there. Okay. So now let's look at our next problem. And I just realized just now that the picture on the next page where we're going to talk about solutions, I forgot to change it out. So it's not this picture. So I'm going to activate the slide, but do me a favor, keep this picture in your mind, not the shoulder picture. Let me clear the answers. Hang on, let me clear the answers here real quick. But remember, we're looking at the picture. I'll go back when we talk about the actual solution, but this is the picture I want in your mind, this water like that. So what's the problem here? And don't look at this picture. Ignore that man behind the curtain. What are the solutions for this problem? Okay. Yeah, that could be a 100-year storm event. And if that happens, yeah, that's a problem. Cut it off uphill. Yep. Better stabilization. Yeah. Larger ditch capacity. You should be able to keep typing in solutions if you've got the website up. It should still be active, I think. Let's just see if somebody puts in an answer. If I go back, does it still show up? Yeah, it does. Okay. So you need to look where it is. The rule of erosion is pretty simple. Once you see the erosion, you obviously have to fix it. But what you really want to do is go upstream until you find the point at which the erosion started. That's where you need to put your solution. Once you see brown water, there's erosion somewhere. It could be caused by exposed earth and rain hitting it. It could be caused by sheet erosion. It could be a pipe that failed. But you got to work yourself upstream and cut it off. Otherwise, you're going to be fighting with it all the time. And of course, once it's eroded, it's really hard to fix. Okay. So yeah, you got to think about diverting the water, maybe ditching, all kinds of things to look at. You know, if you've been to the roadway and roadside drainage class, you've seen this picture. This is the classic example. It erodes even worse behind where I took the photograph. But the real problem isn't where the erosion is occurring here along the roadway. The real problem is way up here by the gentleman in red, where the water couldn't get off. There was a false ditch, and now the water gets into the roadway or into your shoulder. And once it gets in there, it erodes like crazy. And that's the problem for us. Okay. So now in this particular case, what do you think the solution is? Okay. Let me clear the ones you've got already. What do you think the solution is for a problem like this? What would you think about doing here? Bigger crown. Okay. Intercept the water upstream. You got to regrade that shoulder. Yeah. Vegetation control, cut down the high shoulder, especially get those false ditches get built up. You may need to do a little bit more mowing or careful plantings that let the water through but don't create a buildup. Better ditches, possibly. Okay. One of the things you always need to think about, and I'll change my color back here again to blue, is that the crown on the roadway, we talked about the crown earlier on the gravel road, we want that A shape. But even at the edge of the shoulder, I'm going to exaggerate it, we need an extra crown. Okay? We actually need that extra crown because otherwise it builds up over time. And once it builds up to being as flat as the roadway, we get a false ditch, and that's where the erosion starts. So we need to make sure the water can get off the roadway. And then once it is off the roadway, we need to make sure we've done something like you talked about. I got 4 letters for you. They're really important letters. Keep them in your mind. If you don't know these 4 letters, you should get to know them. Soil and Water Conservation Districts, or SWCD. Almost every county has one. If you don't know the folks at your local Soil and Water Conservation District, get to know them. They can provide you assistance. They can help you design things. They can help you find resources. Otherwise, the biggest thing they need is time. You can work with them. They can work with you. I'll actually show you a project we did with our soil and water when I worked over in Yates County here before we're done here. Okay. All kinds of things to do. Great group to work with. So keep them in mind as we go forward. So one possibility is you could line that ditch with gabions or stones, put in diversion ditches to take some of the water away so it doesn't keep going down the road and building up volume and velocity. Okay. And you put a series of these diversions in to bring the water away over time so that it still got safety, doesn't have erosion, and it helps the water get away from the roadway. It's a win-win for everybody. Okay. So all kinds of things to think about doing, and just keep in mind, deal with your soil and water conservation district. Okay. Okay, so lovely looking ditch. Somebody really good with the backhoe. The backhoe work here was excellent. But long term, there could be a problem here. So what do you think is the problem, and more importantly, what is the solution for something like this? It's too deep. It's a safety problem. Yeah. First and foremost, our ditches don't need to be that deep. All they need to do is get in below the base of the roadway. Okay. And of course, if you get too deep, the slope is not stable. So not only is it a safety issue if a car goes off, but it's not a stable area. Okay. In a mile of ditch, before you can even see the erosion, you're going to get about 30 tons of material eroded away. 30 tons. Well, 30 tons of material is an awful lot of stuff. So you're going to have to stabilize that bank. It's not sloped well from either side of the road or the back slope. A lot of issues here. Okay. And of course, where does it all wind up? In the worst possible spot. I took this photograph, and then 2 weeks later, this photograph. Okay. So obviously that's a problem. Where do you think all that is going to wind up? Streams, channels, or worse yet, your culvert pipes, as it erodes down and fills up your pipes or wind up in natural streams, plugs up the pipes that you wanted to have draining things. Okay. So we've got to get the water away. Okay. Of course, about 2 weeks after I took this photograph, the agency came in and put in pipes. Y'all all have budgets for that, I assume, right? No. That tree, by the way, the tree survived. It's still there. It's amazing. But here's the thing is, I'm going to go back to our solutions page. And I'm going to ask you, why is this very common? Why do we see ditches that are steep like this? What do you think is the constraint that causes us to put in such narrow, steep ditches? Somebody mentioned it way early on, and yeah, lack of right-of-way. That right-of-way gets us into a lot of issues. And on most of our town and a lot of the county and village systems, The right-of-way is by use. Nice job, y'all. The right-of-way is tough because technically the right-of-way is only the part that's used and maintained by the local agency. It's not that 3 rods of 49.5 feet. Okay, everybody wants to have that just under 50 feet. And you don't have it. Technically, you've only got what you've used and maintained. You can't go wider than that. Okay. In this case, they had a fixed right of way. It was actually the top of that back slope that you can actually look if you look carefully. I don't think this particular picture has it, but there's actually right of way posts. You can actually see them. If you have to go wider for safety and or drainage, work with the landowner. Okay. Yes, it becomes part of your permanent right of way. You probably should get an easement for it. Do people go outside that with a handshake? Well, there's times when we used to. We probably need to be thinking more permanent than that. But if you can get the landowner to be able to maintain it, maybe everybody wins. Not true, possible everywhere, but that right of way becomes an issue for us. Okay. And yeah, you might have to fill that ditch in at some point. And there are techniques for filling it in that probably should be thought about and followed and used if at all possible. Okay. And of course, it winds up in a slope like this, and then we got a problem. Now we have to deal with all that debris and that washout. Maybe a series of check dams could have helped in some cases if the ditch is steep, things like that. Okay. Okay. So now we got a side hill slope here. Okay. I'm going to ask you, what do you think the problem is, and what do you think is the solution? Okay. And let me, as soon as I get this moved over, let me clear the answers first. Okay, let me clear the solutions. There we go. Okay, so what do you think is the problem? What do you think is the solution here? It's a bearing capacity failure on the side slope. It's too steep, needs to be flattened. Okay, some material in the cuts. Water seepage needs a cutoff ditch at the top. Somebody put in the Q&A a larger stone might have helped. Okay, water weeping out of the slope. Perched water, bulging slope. Okay, there's no swale at the top of the slope, so the water that comes across the top gets underneath and causes it to fail. Yeah. All good thoughts. And this is the reason why, and I keep stressing this because it's so important, we've got to figure out where the problem is occurring. Okay. If you look at a slope, okay, so we're just going to draw ourselves a slope here. Okay, so we've drawn ourselves a slope when my computer will let me. Doesn't want to fill that slope in, but we'll live with this. Okay, so we got ourselves a slope. That slope can fail in about 6 different ways. Okay. One way, and I'm going to just draw a couple of them for you, and I'll do them in, I think we'll do them in black, just because I've got black here. Okay. It could fail because the slope isn't that steep, but there's just water problems. The water gets in underneath, it over pressurizes everything, and it bursts out. You just get too much water and it's soft, whole thing slides. It could be there's problems at the toe of the slope, and you get the whole thing curving like that. You get a failure plane that comes underneath. It could just be at the toe of the slope. The whole thing sloughs and just pushes down. Okay. It could be too steep. And if it's too steep, obviously it's unstable and it can fail. There's about 6 or 7 different failure modes. They usually occur along a plane. Okay. But not always. But you can find that plane to intercept it, and then maybe you can save the slope. Okay. Most of the time, the things to look for, though, is to look at the slope itself, and it can help you figure that out. Now, there's no trees in this particular case on the slope, but on our rural road system, there usually is some kind of slope in there. And so that can help you. So we'll go and look at a picture here. Here's a slope failure. Okay. You can start looking at the vegetation or the signpost or the guide rail post. Okay. They can start telling you something about what's going on. Now, got to be careful. In this particular case, there's some evidence that maybe some of the posts had been hit. But what do you notice about that first post in the photograph? It's tilted back a little bit. And if it's not because of an impact, maybe the whole slope is sloughing off downhill. Okay. If the post had leaned in, you could be getting a curl. Okay. My advice to you, when you start getting slope failures, go get some help. Bring an engineer in, especially if it's a high slope. But think about where the failure is occurring and think about intercepting the failure plane. And don't just drive some posts down through it. You got to be better knitting than that. Okay. Something that really ties the layers together or gives you strength. Okay. And yes, you can protect some pretty steep slopes if you do it right. Okay. And this slope is steeper than one-on-one, but it's holding up just fine 25 years later because there's actually, in this case, a geogrid in there holding it together. The geogrid's not the only solution. There's soil nails, there's vegetative solutions that exist. The idea, though, is if you start getting slope failures, think where the problem is occurring. Don't just assume. Okay? Okay, so now I got one more here that I want to talk about. This is a stream next to your roadway. Okay? You can see that it's eroding the bank and it's threatening your roadway. From where I'm taking the photograph, I'm looking obviously down the stream, but the road comes in behind me. Okay? So what do you think the solution is here? Ooh, fancy word, SAT word. Built-in stone, put yourself a bank along the side. Yep. Armoring of some type. Yep. Clear the obstruction, but be very, very careful. Which obstruction is the one you want to clear? Bank stabilizer, some gabions, possibly. Again, figure it out. You might want to do some stream work upstream to fix the meander. You could use sheet piling. Again, work with the stream. Is the stream meandering normally, or is it actually pretty well fixed and just happens to be probably caused by those trees that fell and caused the whole stream to change slope? Do I remove the gravel bar? Be very careful. My usual rule of thumb is I don't want to remove that gravel bar unless I have to. I'd much rather work on armoring the roadway properly, and then I can always come back in and do something later with that gravel bar. And the reason is fairly simple. Okay, let's see if my pen will give me what I need here. So if we think about the stream from above, maybe it's a meandering stream. Okay, so it's like this. Okay, there's our stream. Okay, it has a certain length to it. Okay, if I drew that length out in a straight line, it might be as long as the line here that's decided it didn't want to connect. Okay, if I straighten that stream out, give me a different color here. Oh, we'll go with light blue just for the sake of argument. If I straighten that stream out, I've shortened that stream up. Okay. The fall of the stream from point A to point B is still the same. So from the side, the stream should have fallen like this. Okay. But I straightened it up. And now it's steeper. I've increased the velocity of the stream. Exactly. There's now more energy somewhere. There's more energy that's either going to cause it to scour up here at the top so that it can flatten itself back out, or it's going to create an erosion. It's going to fill in at the bottom when it gets past that steep point and maybe even create a scour hole as it does it. It's easy to push that problem. You really need to look up and downstream. That's where soil and water can help. That's where engineers can help. But think about working with Mother Nature. Okay? And it's amazing how well that can actually work. If you came in here, in this case, I want yellow. Just remove the trees carefully. Don't touch that stream bank. Put in a proper armoring here with good, what they call spur dikes at the end to protect the bank. And let the stream do what it wants to do. If you don't have to protect both sides, the stream can stay in its natural energy state and be in pretty good shape. Okay? Now, if you're wondering where all that came from, the research that showed all this and how well and effective it is actually came from after the Schoharie Bridge collapse, which many of you will probably still remember back in 1987. One of the outcomes of the research for why that bridge failed was to help us really understand stream stability. And we improved the quality of our streams by quite a bit by not just straightening them out, but think about working with Mother Nature. Okay? Now, obviously, if you get a stream that's incised in a gorge, well, it's not going anywhere. So different problems, and you get a pretty picture. Drainage problems really affect a lot of our roadway system. Okay, in 1 hour we can only cover so much. Okay, so we got a few minutes. We've got the Q&A pod here, and I can even go back here a little bit, and I can clear this. So you could either put in the Q&A pod, or you can put in the solutions page here. Are there problems that you were hoping we talked about today that we didn't talk about when it came to drainage along your roadway and controlling drainage problems? And again, you can either put them in the Q&A pod or just type them into the solutions. It's available and open for you. Well, thanks for the sessions. We enjoy doing them. Environmental regulation interference. That's a great question. And it's one that there's a catch-22 here. Most regulations swing the pendulum. We don't have them, we don't have them, we have them. And they may sometimes go too far. We know that. The danger, of course, the risk that people have is, well, if we don't go far enough. I just listened to a podcast on the Exxon Valdez, and parts of the regulations that were put in after Exxon Valdez probably went too far, but most probably didn't go far enough. And how do we know where that balance is? There's that pushback. And of course, we then have to deal with the consequences. What I usually tell people when it comes to any issues with regulations, try to do the right thing yourself, document what you've done. You don't need a fancy documentation. I'm not a big fan of that. As many people know me, I'm not. But do the right thing so you can show you're doing the right thing and help maybe keep that from occurring. If you do nothing, then regulation comes down the pike. Maybe too late. You're going to then have to follow through with something that may be a bit onerous. But keep in mind how that pendulum goes. Someone asked here, what's my take on head walls versus no head walls when it comes to culverts? I usually look at head walls from an operational standpoint. If you think about head walls on a culvert from a capacity standpoint, they only increase the capacity of the culvert to carry flow or water 5-10% at best. Usually it's operational reasons why I would want a head wall, because it retains the fill. Or it maybe can buy less pipe. The problem, of course, with head walls is they cost a little bit and they have to be maintained. A mitered pipe I really like as well, where you actually put a cross slope in front. But again, they tend to be prone to problems with the end of the pipe, and they may need to be armored and anchored. It comes down to the site. The biggest concern I have with projecting pipes, which are still the most common, is they're more prone to erosion. They're all effective, but they can work in different ways. Okay? So with that, we got a couple of minutes. I see a suggestion here for a different webinar. We need more on snow fencing. We'll keep that in mind. Maybe we can talk about snow fencing. If we do that, we'll try to do it maybe over the summer as you're getting ready for the winter. Ultimate solution for early retirement. Well, we all like what we do. We're amazingly good at it, even though some days it feels like we're under the gun. With that, I want to thank you. You can go to our website, get a lot more information. You can email me. I'm glad to answer your questions. Hopefully, we'll see you for some additional. We have 3 more webinars coming up here in the winter. And once my computer decides to say hello, I will show them to you. So we have our Bumper Banter webinar on Bumper Banter on Mondays, and then our Topical Tuesdays. We've got a Snow Nest Chemical one next Tuesday, work zones the week after that. And then the last one on construction management, especially regarding federal aid on March 2nd. And that's actually going to lead to a longer series if you're interested. It's the introduction to see if you're interested in those kind of things. Also, we have our spring workshop starting up virtually first and then into the field in April. Please go on our website and sign up. We are still looking for summer interns. Yes, we are going to run something depending on how many people we get, even with COVID. We just may need to make some modifications. How exactly we do that depends on how many people sign up. And of course, our Build a Better Mousetrap competition is open. We're looking for your ideas to share. We've won 2 national awards in the last 3 years. We'd really like to keep that trend going. So with your help, you got a cool idea, share it with us on anything you do, from working in the office to working in the field. And with that, there's our website. You can go on there, get good information, send us an email. And thanks again for all the good interaction. Hope you enjoyed it. It's about 10 o'clock. Everybody have yourself a great day. Be safe out there. Be kind.